Hi everyone, welcome to our first tutorial video from uniAssist. So this is one of the most classic problems that you'll get in first year physics or high school physics, and it's the inclined plane. So our first question is, when a force F is applied to a block on a frictionless inclined plane, it moves with a constant speed of v is equal to 1.39 meters per second up the inclined plane. The block has a mass equal to 8.81 kilograms, and the plane is inclined at an angle of alpha is equal to 26.6. So what I like to do first is just to look at how many significant figures we need for the question, because that's really important. Every physics lecturer will look at this when you do a question. So how do we determine how many significant figures we've got? So we look at all the variables in our question. So we've got velocity is equal to 1.39 meters per second. Mass is equal to 8.81 kilograms. And my alpha is equal to 26.6 degrees. So every single one of these variables has 3 significant figures. So our answer in the end needs to be the minimum significant figures that our variables have, and the minimum that we've got here is 3. So we'll definitely remember that we need 3 sig figs for our answer. So we can just keep this to the side and make sure you don't forget that. So now what I like to do is draw a diagram of the question. That's always easiest way to start any question, just so that you have like a visual way to understand what you're trying to do. So inclined plane. So we've got our mass m here, and it is on an angle of alpha, which is equal to 26.6 degrees. And this is our right angle. So what the next step is to determine your coordinate system. This is very important because, as you know, forces are vectors, and vectors have a direction and a magnitude, and you need to be able to resolve the vectors, and they have their own coordinate systems, so you need to be able to add them up together in their respective coordinate systems. So what we've got here is determining our coordinate system. So what I like to do is think about where the motion is. So the plane is moving, sorry, the block is moving in an up and down direction like this. It doesn't move in the y direction because we haven't been told it moves in the y direction. So I like to define my x direction in the direction that the block is moving, or the y direction, doesn't really matter, but this is going to be my x direction. And then my y direction is where the normal force is on the block, so I'll choose this direction here as my positive y direction. You can do it in any way that you choose, but you just have to keep in mind that your force has to be respective of that coordinate system, including the direction, so your positive and your negative. So we can have a look at our first question now that we know how our coordinate system is set up. So our first question is, what is the magnitude of the force acting on the block? Now, if we look at the actual problem statement, it says when a force is applied on the block, it moves at a constant speed. So, speed or velocity. So, our constant velocity indicates that there is no force on the block in total, because if there was a force on the block, then our body would be accelerating. Since we don't have an acceleration and it says it's a constant velocity, we can say that our total force, so F net, is equal to 0 newtons. Our second question is, what is the mass of the normal force that the inclined plane exerts on the block? So what I like to do at this stage is to define my forces, and I do that using a free body diagram. Free body diagram is pretty much a simplified version of the block or the mass and every single force that acts on the mass. And every physics lecturer will tell you that that's the next step to do when you're trying to resolve any force questions. So I like to represent my mass as a point, or as a single point, and then draw all the forces that are acting on the mass. So the first force that I think is always the simplest is my gravitational force, which acts directly downwards on my mass, and I will call that Fg. Then my normal force is the force that is opposite to what keeps the mass on the plane from moving. So that's my Fn, and it's in the direction of the plane itself, in the opposite direction of the plane. And then we've also got a supplementary force to this question, which is called F, that moves the block at a speed which is defined above. So this is my simplified force diagram. Now what we've got to do is separate the forces into their respective x and y directions as we defined above here, because we can't just add the forces like this. They're vectors, they have an x direction and a y direction, so I like to separate them now. So my gravitational force, I'll just draw it on the side here, just to make it clear, is pointing downwards. Now, if you remember your vector addition, it will have an x component and a y component here, which I will call my fgx and my fgy. So if we go back to our block diagram, we need to determine the angle that we've got on this diagram here. So I'll just draw a representative here. So if we go back to our block here, my force Fg is in this direction, and we can see that our alpha is here with respect to this Fg. So I'll just draw that out on my diagram. This is my alpha. And now we can determine where the alpha sits with respect to g, because we need to resolve it into our components. So if this is alpha, this is our right 90 degrees here on both of these triangles. And if that's our 90 degrees, then this angle here is alpha minus 90 degrees. Therefore, if this becomes so this angle here is 90 minus alpha. And if these two angles add up to 90 degrees, this angle here will be alpha. Easy. So now we can define our Fg x and Fg y. So I'll draw it back here again for illustration. Fgx and Fgy. So we've got our alpha here, and now we can say Fgx from just using cosine and sine. Fgx is equal to Fg multiplied by sine alpha. But you got to remember that as we defined our coordinate system up here, you always have to go back to your coordinate system. My positive x direction is in this way, and my positive y direction is in this way, so my Fgx has a negative sign in front of it, and I'll call that Fgx is equal to negative Fg sine alpha. My Fgy similarly will be my adjacent, so that will be negative Fg cos alpha. Negative again because my positive x direction is in this way and my FG is acting in the opposite direction. So now we have resolved our forces, but what the question is asking for is what is the normal force? What is the magnitude of the normal force? And to answer that question, my normal force is acting in my y direction, as you can see. So the magnitude of the normal force we can determine by looking at the total force in the y direction. So this is my sigma total force in the y direction is equal to, so what does that equal to? So we know that the block is not moving in the y direction, it's not accelerating in the y direction, and it's just sitting there. So that means that my total force in the y direction is equal to 0. And that is the addition of all the forces in my y direction, which is equal to my Fn plus my Fg in the y direction. Which means that 0 is equal to my Fn plus Fgy. Fn is equal to negative Fgy. Now, that equals to negative, so we've defined Fg up here, which is mg, so that's just my gravitational force, multiplied by cosine alpha, which is equal to, I'd like to keep all my significant figures before doing my final answer, because rounding up before that decreases your accuracy normally. So I'd just write 8.81 kilograms multiplied by my g, which is my gravitational acceleration, 9.81 meters per second squared, multiplied by my cos, 26.6, and that gives you a total answer with 3 significant figures of 77.3 newtons. And you have to, in exams, write your units. Don't ever forget your units, because otherwise lecturers just love to decrease your points for that. So that's my final answer, 77.3 newtons. Our final question is, what is the magnitude of F, the force pulling on the block up the slope? So we always go back to our free body diagram. We can see this is our F that we are looking for, and it's acting on the x direction that we once again defined up here. So as you can notice, I keep going back to my coordinate system and my free body diagram. So that is why it's really important to define that in the beginning of your question, so you're not stuck forgetting where your directions are, where your forces are, and how to define your positive and negative signs. So once again, going back to the main question, it's saying that our block is moving at a constant velocity, which, like I said before, means that our total force is 0. Because if we had a force, our block would be accelerating, and the question would specify that, but it's saying it's moving at a constant velocity. So, our total force in our x direction, just like I did for our y direction, is also equal to 0, which is the addition of my x directions, every force that's acting on my x direction, which is my F, plus my Fgx. So F is equal to negative Fgx, similar to above, which is equal to negative, we've written it up here, let me just write it back again. Negative, because that's how we defined it, as Fg multiplied by sine alpha, which is equal to mg, just like we had above, sine alpha. So that in total, again, I like to keep my significant figures, is equal to 8.81 times by 9.81 0.81 multiplied by sine 26.6, which in the end is equal to 38.7 newtons. Don't forget your significant figures. So that's the end of this question here. Thanks for watching our first video. Don't forget to like and subscribe this video, and also like our Facebook page. And if you guys have any questions or comments, just write it in the comment section below, and let us know if you have any other questions that you'd like us to do in the future.